All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria, binary, cross-entropy, loss module. Let's have a look at what we went over today. Now, yesterday, if you recall, we went over the process of plotting our charts and going over the actual and predicted values for our equation. And today, we're going to pick up where we left off, but we're going to modify things a bit to play around with the numbers and see what kind of different outcomes we can get. So now let's modify this. Let's say we have a 0 for the actual and a 1 for the predicted. So this is our original equation with no values. Yesterday we had a 1 for the actual and a 0 for the predicted. For this example, we're going to have a 0 for the actual and a 1 for the predicted. So in this case, we will have a similar outcome to the scenario we had yesterday. This is because we'll have y equals 0, which is the actual equals 0, and 0 times whatever the p or predicted is equals 0. So remember, this is our y and this is our predicted. So it will be 0 log of 1. So it will be 0 times 1 equals 0. Next, we will have 1 minus the actual, which is 0. So 1 minus 0 equals 1. So this was originally 1 minus y equals 1. And as we know that y is 0, so we have 1 minus 0 equals 1. Lastly, we will have 1 minus predicted, which is 1. So 1 minus 1 equals 0. You remember this was the predicted, so we have 1 minus the predicted, or 1 minus 1 equals 0. Again, this will leave us with a large value because of 0, which will take us towards a negative infinity on a plot chart, like we showed you yesterday. When x was leaning towards the 0, it was heading towards an infinity type character, or a very large number. And then we will have 1 times that big number giving us a big number, because 1 times anything will be itself. So if we have a big number times 1, we're going to get back a big number. And so our model is sanctioned because it hasn't correctly predicted the expected output. Now let's suppose that the actual is indeed 1 and the prediction is also 1. So this is the original equation that we always start with. So this time we're going to imagine that the actual is 1 and the predicted is 1. So in the case, we would have 1 log of 1. This would be 1 log of 1 because the actual is 1 and the predicted is 1. And then we have 1 minus 1 because we have 1 minus the actual, which is 1. So 1 minus 1, which will give us 0. And then we will have a log of 1 minus p, or predicted, which is also 1. So it will be 1 minus 1, which is also 0. As you can see here. But in our second step, because we have 1 minus 1 equals 0, and this 0 and the 0 from step 3 will cancel each other out, we will be left with the step 1. And remember, step 1 was 1 log of 1. And according to our plot chart, when x equals 1, log of x equals 0. So 1, so log of 1 is 0. And we have our final answer of 0. So our final output will be 0, telling us that the model has done its job correctly. Now that's how far I'm going to go with it right now, because we did start taking some code afterwards. I didn't dive too deep because I wanted to focus mainly on the math. I spent most of the morning just diving into the math. When I got to the code, I went back and started doing the math again just to make sure I had a handle on everything. And I still may do it a third time anyway, just to make sure I fully got everything down pat. But of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.